Welcome to this video, where we will have a look at another designing example. This time it is our task to design a tube bundle heat exchanger for oil cooling. Its performance is 14 megawatts. The maximum allowed pressure drop for the thermal oil is 100 millibar and the maximum allowed pressure drop for the cooling water is 250 millibar. Let's get right into it. We start the Lauterbach software and open the module WTS. We type in the inlet temperatures of the thermal oil and the cooling water, the mass flows, the performance, 14 megawatts, the heat exchanger configuration, and, which is very important, the inner diameter of the heat exchanger. After scrolling down in the module, we can see that both maximum allowed pressure drops are not exceeded. Now we want to perform a strength calculation. WTS automatically starts the module WCAD. This module finds out how big the forces applied to the tube plates are. We type in the TEMA type, so which kinds of front head, shell and rear end we have on our heat exchanger. We select a bundle, because we have a tube bundle, and calculate using AD2000. After putting in all our information in WCAD, the module B51 starts automatically. And after scrolling down, we can see that the actual buckling forces are bigger than the required or allowed forces. So we have to change something in process engineering. Back in WTS, we change the number of baffles per pass from 14 to, let's say, 21. And we can see that the inlet baffle spacing has changed from 400 to 304 millimeters. Now, back in module B51, we can see that the actual buckling force does not exceed the required buckling force. But back in WTS, we can see that the velocities, tube side and shell side, have increased significantly. And therefore, the pressure drops have also increased. And on the right side, we can see that the shell side pressure drop exceeds the allowed 250 millibar. Since the baffle spacing is fixed, the only way to reduce the flow speed and this way to reduce the pressure drop is to increase the shell diameter. Let's say from 711 to 1200 millimeters. And after checking, we can see that now both pressure drops are not exceeded. Now we also want to perform a thorough strength calculation considering the stability of the saddle, excessive stresses or potentially dangerous bulging of the shell. Therefore, we open up the module FELV. We select a vessel with saddle support, type in the boundary conditions, material data and geometrical data and so on. In the top left corner, the button Start COMSOL app starts COMSOL Multiphysics. In COMSOL, the button Calculate starts the calculation of all the stresses, and in FELV you will find all the results, all the calculated stresses in a table. This is a table that contains all the results from the COMSOL calculation. As you can see, the total maximum utilization is 115%. You have to consider that this analysis and calculation has been performed rather conservatively and considers local stresses plus peak stresses. You have to keep in mind that a global stress calculation considers higher safety factors than local stress calculations. So, in summary, you can say that this vessel on saddle supports is safe for use. In the different tabs in COMSOL, you can have a look at the model, the shell, and also at the deformation. The coloring on the model gives you a look where the deformation is especially strong, which does not mean that the construction will necessarily burst. Optionally, you can perform a buckling analysis. The result of the buckling analysis will show you where the bulging is especially strong on your model. Also, you can see that the critical load factor is about -3, which means that the whole construction, the whole vessel is safe for use. In the beginning, we have designed the heat exchanger, and using COMSOL and other modules in Lauterbach, we had a look at the strength calculation of the heat exchanger. I hope this video could give you a closer look on how to use our software and what tasks you can solve using it. If you have any questions, feel free to ask them, write us an email or just call us. Goodbye and see you next time.